Here we'll solve an equation using the distributive property of real numbers. Let's look at this equation. Make sure it's an equation first. We need to solve for the unknown, which is z. And notice in the equation, the exponent of z is 1. So it's called a linear equation in z. There's just one variable, and that is z. Everything else is a constant. Now, solving for z is the same as isolating z on one side of the equation. So let's first use the distributive property to open the brackets here, open the parentheses. So the distributive property works this way. Suppose we have a times m plus n. So let's see, we have a times, so this is the same as a times m plus n. So this is times, so that's multiplication. And inside the parentheses, we have addition. We have the sum of two numbers. Then the distributive property says we can open the parentheses by going a times m plus, so you distribute the a, m gets an a, so we have a times m, and n gets an a. So we have am plus an. So that's called the distributive property. So if we have 2 outside, 2 parentheses 2z plus 3 is the same as 2 times the quantity. So when I say the quantity, what I'm talking about is the parentheses. So it's times the parentheses m plus n inside. So then that would be 2 times 2z. So let's write it as 2 times 2z plus 2 times 3 equals, and on the right side of the equation, we have the exact same situation. We have 3 times the quantity z plus 4. So that would be 3 times z plus 3 times 4. So notice there's a plus in between the two because of the plus here. So that's 3 times 4. So we've used the distributive property on both sides. Now 2 times 2z is 2 times 2, 4. We just multiply the numbers. So that's 4z plus 2 times 3 is 6 plus is equal to 3z plus 3 times 4 is 12. So now we have an equation in a familiar format. All we have to do is isolate the z's on one side. So let's get rid of the 3z on the right by subtracting it out on the right. If we subtract off 3z on the right, we have to subtract 3z on the left as well for the equation to be balanced. So we have 4z minus 3z plus 6, so the 6 remains, equal to, so don't forget the equal to, always write both sides of the equation. 3z minus 3z is 0, plus the 12 remains. So we have 4z minus 3z, which is z, plus 6 is equal to 0 plus 12 is 12. So now, remember, our goal is to isolate z, which means we need to get rid of the plus 6 on the left. So we need to subtract out 6 because 6 plus 6 minus 6 is 0. When we add plus 6 and minus 6, it is equal to 0. But we do the exact same thing on the right side. So z plus 6 minus 6 is equal to 0. They cancel each other off. So if some number is added, like 6 is added to the left side, so therefore we subtract it out. So we do the opposite. So plus 6 minus 6 equals 0. 12 minus 6 equals 6. Now z plus 0 is z. Adding 0 to a number does not change it. Equals 6. So this is our solution, but let's just double check our answer by plugging it back into the original equation. So we have 2 times 2z plus 3 equals 3 times z plus 4. So this is equal to, let's plug in the numbers. The number z equals 6, so 2 times 6 plus 3 equals 3 times 6 plus 4. So 2 times 12 plus 3, 6 2s are 12, plus 3 is 15, plus 3, is equal to 3 times 6 plus 4 is 10, 15 times 2 is 30, and 3 times 10 equals 30. So 30 equals 30 tells us that the equation is still balanced, which means z equals 6 was a correct solution. So that's one solution to the equation. So here we've used the distributive property, and once again, let's quickly write down the distributive property. A times m plus n equals a times m plus a times n. So that's the property we used to simplify both sides before we solved the equation.